Again, this is the most, and I might just do a whole test on chapter 10. I don't know how I'm going to break up the test. I don't know if I'm going to do one test. I don't know if I'm going to do 3 tests. I don't know yet. Okay? The more tests, the better for you, right?
Yeah.
Okay, so let's just keep it talking like that. Am I recording? I am recording. Okay. Okay. When do you use the law of sines and law of cosines? When you don't have 90 degrees. Basically. So you can write all 3 of these down, or you can say when you don't have 90 degrees. You have side, you have angle, side, you have angle, side, angle, or you have side, side. Okay? I'm not gonna, you don't have to write all 3 of those paragraphs. Just write side, angle, side, angle, and side, side. What?
I remember that right there from math class.
Which one? Just curious.
High school.
Oh, high school.
Yeah, I remember
Okay.
geometry.
And a lot of you should remember the law of sine and cosines, because that's one of those things that you have to know to make your money for your high schools. You know, coaching for tests, coaching for dollars. And they coach you for the, what is it now? It's not the SAT, it's the ACT.
ACT.
Yeah, when they coach you for those tests so they can get money, they make sure you know the law of sines and the law of cosines, just like they make sure you know how to do Oscar had a hunk of apple, because that is filled on standardized tests. So the law of sines and the law of cosines is on there. Okay? And that's basically, I'm not going to tell you that side means 3 sides are known. I'm not going to tell you that because most of y'all know that. Okay? And here is some examples of when you have right angle trig versus the law of sines and the law of cosines. Now, with the right angle trig, the reason we have right angle trig is for triangles that have a what in it? A right angle, a 90-degree angle. But when you don't have a 90-degree angle, when you have an obtuse angle or an acute angle, then you're going to have basically, and this shows the derivation of the law of sines. Okay? And basically, if you take this and you bring it out here, or you take it and you move it out here, that's how you basically get the law of sines and law of cosines. I'm not going to derive it for you because, to me, you don't need to. You can write it down right there if you want to, but this is pretty much self-explanatory. And we'll get to the law of sines and the law of cosines, law of sines in just a second. There it is. So write it down. It's one of the easiest things to remember in trig. Actually, these first 2 sections are going to be the easiest sections, basically, next to right angle trig in the first section that we had. So this is where you can really shine as far as if you sucked on the last test, which you should not have, unless you took it 4 or 5 times and you still sucked. And if you took it 4 or 5 times and still sucked, then you didn't know it at the beginning. Okay? If you took it 1 time and you flunked and didn't take it no time, then I don't feel sorry for you at all. Okay? But this section, you should be able to ace at least the first 2 sections of homework without any problem. All it is, plug and chug and algebra. Solve a triangle ABC if A is 32, B is equal to 81, and A is equal to 42. Now I want you to draw a picture. Now, do you have to worry about scale, and do you have to worry? No, you just draw a triangle. Okay? You know that one angle is 32. You know the other angle is 81, so you know what the third angle is because they're equal to what?
180.
180. So you know that. So you know about how to draw it because of the angles. You know the 32 is around a 30-degree angle. You know 80 degrees is close to 90 degrees, and that'll leave whatever the third angle is. You know that the corresponding side A is opposite from angle what? A. So you can draw it however you want to, but the pieces will be in the same place. Excuse me. I'm going to take my handy-dandy black marker. And again, I don't know how many of you, I remember from the first week of class, there was 3 or 4 of you at the Pendleton campus that hasn't had trig in a while. And I think there was 1 or 2 at the Easley campus that didn't have trig, like last semester, or not like trig, but, high school trig last semester. Miss Crittenton, remind me about your trig in high school.
It's been years. I did it in high school, but it's been a while.
Okay. So, and Anderson, some of y'all have had trig. I think 2 or 3 of y'all. So some of you may need a refresher on how to draw it. I don't know. But I'm just going to say that angle A is 32 degrees. So I'm just going to draw a 30-degree angle like that. And I'm going to say angle A is 32 degrees. And I'm going to say big A right here. And I'm just going to go over here. And I know that angle B is next to what? 90 degrees, but it's not. It's kind of inward, right? So 90 degrees would be what? Right there. So I'm just going to say, I'm going to erase that, and I'm going to make it a little bit closer. Technically, there's not a wrong way to draw this, even though some of y'all could break an anvil with a banana, but most students, there's 90 degrees, so 81 would be what? Like right there? Something like that? And then that leaves this angle right here, which we don't know, and this is 81.8. That's angle B. So by law of deduction, this is angle what? C. And we know that since this is angle A, this over here is side A, and we know that side A is 42.9. Oh, I have to tell y'all about my faculty staff development day. I got to tell y'all about that. 42.9. We wasted a whole day. We went to Pendleton campus yesterday to have faculty staff development day. And one of the sessions that we went to was innovative learning. Y'all ready?
Ready.
Innovative learning. We had to walk around a lobby and look at about 6 to 10 posters. Now I want you to think about that for a minute. Innovative learning, 2019 or 2018, almost 2019, and posters. Somebody tell me what's wrong with that picture. When was the last time you used a poster? Last time I used a poster was like in the 3rd or 4th grade. But that's innovative learning. I tell you what, I was in the Marine Corps for years and I knew what clusters were. I can't say the second part. But right now, Tri-County Tech is in a cluster. When we think innovative learning is walking around looking at posters.
Yeah, posters of the future.
And we got people turning the camera because they can't turn on the presentation screen. And we got a whole committee of doctorate and master's degree that don't know when you got a blue screen to lift the lid off the camera. Innovative learning. I had to throw that in there because I have to vent. Okay, I'm okay. So, A over the sine of A is equal to B over what? Sine of B equals C over sine of C. Now remember, you have sine of A, sine of blah, 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 blah. So it doesn't matter which one you pick. But I'm going to pick B because I have B, right? I don't have anything for C, so I'm not going to use C at all. So just kind of mark through C because we don't know what C is. Now you could go through and say 32 plus 81 is 113.8, and then 113.8 from 180 is going to be what, 66.2. Okay, so you know that's going to be 66.2. You could do that. But we want to use sine A is 42.9 over sine of 32 is equal to B over sine of 81.8. Now it's time for the calculator drill team. You have approval to spin the calculators on your fingers like a basketball. This is the time that you can shine, calculator drill team. Do it in 2.3 seconds. Cross multiply, and you get B sine of 32 equals 42.9 times sine of 81.8, and B is equal to 42.9 times sine of 81.8 divided by sine of 32. And somebody give me that number. Calculator drill team's getting a little rusty. That's a good thing. And believe you me, that is a very good thing.
I'm not part of the calculator drill team.
Well, some people are. Some people name their calculators. Some people have a little bed beside their bed for their calculator, a little pillow.
That's adorable. I have D1 offers.
Some people sacrifice live animals to their calculators.
Oh, that's less than.
What happened to my dog?
No, I taught a college algebra, one of my first college algebra classes back in the day, a long time ago. And back then, oh my gosh, it was awful. I mean, you couldn't ask somebody the square root of 25 without using a calculator. I mean, they were that dumb. And I said, everybody get your calculators out. And it was like the silent drill team at Ethan I, the Marine Corps silent drill team. It was like, whoosh, whoosh, whoosh. And I was like, oh my God. And that's where I came up with the calculator drill team. I mean, it was synchronized cover removal.
My friend was on a solid drill team for Greece.
Were they? They're bad. Okay, so somebody give me the number.
I got 80.1.
80,
I got
80.17.
Okay, first of all, make sure everybody is in degree mode.
Yeah, I'm in degree.
Okay. Let's go with somebody at Pendleton. Let's get 3 answers. Okay, let's see what's Pendleton. What did you come up with?
80.1.
Okay, easily.
Yeah.
What did you come up with?
80.1.
Oconee. Miss Crittenton.
I don't have my calculator.
She's on drugs. No, just, intervention. We need to have class intervention with Miss Crittenton. You don't have your calculator, Miss Crittenton? She pawned it. That's all right. And what did y'all get? Y'all get 80.1?
80.1.
Okay, so B is equal to 80.1. Okay, now I want you to find C. Find angle C and side C. Of course, you can use whatever you want to, but you need a couple of more steps to do that. I want you to use, don't use don't use the 180 degree rule. I want you to use sine A, sine equals the sine C. Okay, you're gonna have to use 180 degrees. So what is? Well, no, you don't. You got side angle side. You could actually. You have side angle side. No, you don't. You don't have side angle side because you don't have C right here. So you're going to have to use. So 180. What did we say it was? C is equal to. What was it?
66 point something.
66.2. What was it?
Sounds about right.
66.2.
Okay. So by using the 180 degree rule, now you can find side C. So what you want to pick, A or B? A. So A is 42.9 over sine of 32 is equal to C over the sine of 66.2. And I'm going to put this kind of like part 2.
It doesn't matter which one you use?
No, it does not. That's the good thing about law of sine and law of cosines. It's hard to break this amble with a banana. Although somebody will. So C times the sine of 32 is equal to 42.9 times the sine of 66.2. And I'm just going to divide by the sine of 32 and divide by the sine of 32. And that's going to be our answer. Oconee. Okay, you don't have a calculator. Easley, what did you come up with?
74.1.
Pendleton, did you get 74.1?
Yes.
Anderson,
I got 74.
74.1. We have somebody on drugs here. We got somebody that's getting 1 or 2 off every single time. That's using a Sally Homemaker that they bought at Walmart for $9. So I'm going to erase this, and let's see if I know what I'm doing. That's what it looks like. 80.1. Everybody got that right? Woo! Everybody should carry around a jug of water. And then find 66.2 and then 74.1. So you see that these problems are not what? They're not that difficult. Now, sometimes they may throw an X in there. Sometimes they may say one side is larger, but that's where your algebra comes in. As far as the only new material in 10.1 and 10.2, the only new material is the law of sines and the law of cosines. All right, look at this one. 2 stations on an east-west line. That means you got a flat line. Flat line. Okay? A forest fire is located on a bearing of north 42 east. So there's north 42 east right here. North 42 east. That means that this angle right here is what? Dang old 38 degrees. Why? Dang old complementary angles. Dang old back a long time ago. Okay? This angle is 15 degrees. Therefore, this angle is what? 100 and what? 105 degrees. Now, if you don't know where I got the 38 and 105, you need to go back to Unit 1. Or you can just quit now. Yeah, McDonald's. I think there's somebody else hiring. I saw it on Facebook this morning. I can't remember. No, it wasn't Walmart. It was somebody's hiring.
Taco Bell.
So what is 38 plus 105? 38 plus 105 is what? 143?
43.
So therefore this is 37. Y'all check my math.
Yes, it's right.
Now you're ready to go. I don't know what they're asking for, but we're going to find everything. Is that a good thing to do when you're doing these problems?
Absolutely.
Yes. Unless you have LAD syndrome.
Yeah.
Y'all can figure out what LAD stands for. Sine of, the last word is disorder. The first word is lazy. Sine of A equals B over sine of B equals C over sine of C. Now your first thing is to say, what do I have? What am I looking for? First thing. The one thing that you have is you have side C and you have what? Angle C. So you've got this guy right here. You've got that. So you take your handy dandy green highlighter and you highlight this guy. Well, I'm not even going to try it because you've got that covered. Now you just take your pick. Well, I'm going to find, they got B there, so we're going to find B. So I'm going to go with B. So I'm going to go with this one because they have it listed there. And then we're going to find angle A. We're going to find, side A. We're going to find all of them. So B, we don't know. sine of B be sine of 105 is equal to 110 over the sine of 37. Cross multiply, solve for x. So that's going to be B is equal to 110 times the sine of 105 divided by the sine of 37. And somebody crank that out.
Shouldn't that be 48 instead of 48?
Yeah.
Angle A?
I'm sorry, you're right. Thank you. 48. Thank you, whoever said that. So 48, so we don't need it on here, do we? Thank you. Well, that would change this one. 48 and 105 is going to be 150, what? 153. And that's going to be 27. Somebody check me. I asked y'all to check me a while ago and y'all didn't check me.
Yeah, that's right.
So that's going to be sine of 27, sine of 27. Now crank it out.
It's 301.
And since your calculator don't work right, you're not allowed.
No, it doesn't work. Right.
Which one of your calculators don't work.
No, you got it right.
You're off by 1 digit every time.
I got 388.
I'm sorry, what'd you get?
Sorry, it's probably wrong.
Okay. Mr. Self-Confident here, he don't want to answer it. Pendleton, what'd you come up with? Okay, I'll ask it again. Pendleton, what did you come up with?
234.
Okay, we got a 234. How about Easley?
234.
Okay, Anderson. 234. Is it 234 even?
It is.
All right, now find angle, that's equal to 231. Now find side A. Now, it's very important. If anybody's got questions, go ahead and ask now, because you're going to be building on wet sand if you don't. Because this whole chapter is going to be based on law of sines, law of cosines, and right angle trig. Some people don't even understand building on wet sand.
Sounds smart.
Hmm?
Sounds smart.
I don't want to confuse anybody. So, is there anybody going to be able to beat Alabama?
Probably not.
This is a Georgia fan saying, hail to the no.
Maybe, no.
Yeah, QB ain't putting money on it.
No.
After watching them annihilate LSU the other night,
Yeah.
ain't nobody going to be able to beat them.
I wouldn't be too sure.
Not even my dogs.
They can do anything if they put their minds to it.
No, whatever. They're going to get their ass beat.
No.
If Georgia can't beat them, I know dang well Clemson ain't going to be able to beat them.
Too far.
Think Notre Dame can beat them?
No.
Well, that's the same thing.
Oh.
No.
Okay, who was Notre Dame played?
Buddy.
Okay, who was Clemson played this year?
To beat Michigan week 1.
Oh, Notre Dame beat who?
Michigan week 1.
Okay, well, that was at the first year though, wasn't it?
Yeah, that was like the first game. That's
Yeah.
Well, I mean that's good, but I hope Michigan beats Ohio State to death.
Yeah.
No, I don't.
No,
I don't care nothing about that. I just want Ohio State to go down to number 26. But they never will go down to 26 because they won't let them go down to 26. Okay, I'm going to open it up. Who do you think can beat Alabama?
Clemson, Georgia.
Georgia can.
You think Georgia? Okay, well, you're better paying than I am.
I'm not saying 100%, but there's a slight possibility.
Oh, yeah.
You have to go with someone's
I would
defense that's
say,
strong.
if you want to ask my probability, I'd say a 0.3 probability that Georgia can beat Alabama.
I'll say Clemson could actually hang.
Clemson is going to hang.
They could go control the ball with all those halfbacks.
Our whole front line is.
My problem with Georgia is Georgia can score, but they're not going to be able to stop. They're not going to be able to stop. Georgia's defense is not going to be able to stop Alabama.
ESPN says that Alabama has a 67.1% chance of winning, while Georgia has a 32.9% chance of winning.
Hey, that's a good percentage.
Thank you.
I'll take 32 over 23.
What's the chances for Clemson? Look up Clemson and see what they say.
They don't.
They might.
I mean, they'll put it on there when they do, but.
Oh, okay. I see what you're saying. Okay.
I'm on the app.
So nobody thinks. What do you think the probability of the Clemson beating Alabama?
I'd say about.
You giving them that much?
15%.
No.
I get a little more than that.
I would say 15 to 30%.
I'm sorry. What?
42%.
What'd you say, Pendleton? I heard
40%.
we got 44% here at Anderson. Pendleton says 40.
We'll say 40.
What does Easley say?
They don't know what they
Really
want.
nothing.
Okay. Easley don't care. What do you say, Miss Crittenden?
I would say no more than 20%, to be real.
I agree with you on that one. I believe Georgia has a better chance of beating Alabama than Clemson does.
I agree.
Because Georgia's got a tougher schedule.
Oh.
Clemson has a better defense than Georgia.
What?
Clemson.
Clemson has a better defense, even though
I'll
Georgia.
give you that. Yeah, I'll give you that.
But defense wins games, not offense.
I don't know.
Well, I don't think we're not going to have a chance. I think we're going to have a chance to see both Georgia play Alabama and both Clemson play Alabama. Does everybody agree with me on that?
Yeah.
But I don't think Alabama is going to be deterred by either one of them.
Alabama has two
Not as much anymore.
quarterbacks that can
I used to play.
Well, one of them gets out of the wheelchair.
Yeah.
Before right.
They were saying, yeah, he could play in emergency. He was walking across the field like this. I'm like, an emergency?
Really yards though.
Alright.
A touchdown.
No, he just got out of surgery.
I don't play ranked. I've never played ranked.
All right, so, okay, we better stop because somebody will complain. All right, so we got A over sine of 48 is equal to, take your pick. If you want to pick B, you pick B, 231 over sine of 105.
Should be 234, I believe.
Okay, thank you. Didn't. All right, 234. And crisscross, you're going to have A is equal to 234 sine of 48 over sine of 105. A is equal to 234 times the sine of 48 over the sine of 105. And somebody just give me a whole, don't give me no decimal, just,
It's 180.
how much?
Should be 180.
180?
Hey, I got that too.
Everybody got it?
Yeah.
See? Y'all ain't breaking amble with banana. Looks like y'all are doing this. I told you it'd be easy.
I like it.
All right, let's keep going. We got to discourage you somehow.
Oh.
You got to get to a point where you don't know what you're doing. $234, y'all got that right? Y'all are special. For any angle, -1 to +1, if the sine is 1, then we already know this. We know it back from first unit. That's why the first unit is so important. Supplementary angles have the same sine value. The smallest angle is opposite the shortest side. Write that down. The smallest angle is always opposite the shortest side. Now, if you think about that in real life, is that true?
Yep.
Okay, if you turn a horizontal angle or vertical angle of 2 degrees, that's going to be a very small angle. You turn it 4 degrees, it's going to be a bigger angle. So the bigger the angle, the bigger the side. All right? So you need to highlight that because sometimes when you're doing these puzzles, and I call them puzzles, when you're trying to fit everything together, that's going to come into play. And the largest goes with the largest, and the medium goes with the medium. So if they don't give you side A, B, and C, then you're going to have to fill in, you're going to have to put the puzzle pieces, whatever, puzzle pieces in place. Okay, there's the example I was trying to show you. All right? Pretty much self-explanatory. Oops, sorry. There we go. There and there. Okay. Solve the triangle A, B, and C. If B is equal to 5540, side B is 8.94, and side A is 25. So side A is smaller than side B. So what in the heck are we going to do? Well, first of all, angle ABC. If B, so I'm just going to draw B. I'm just going to think this is angle A, and this is angle B. Okay, I don't know what the triangle looks like, but I do know that 55 degrees is about half of 90, right? So if I just draw a line right here and a line right there, that's 90 degrees, right? So I'm going to divide that, and I'm going to say, boop, and I'm going to call that angle right there 55, 40. And then therefore, side B right over here is 8.94, which is going to be kind of like that, 8.94. Okay, I'm just going to go ahead and draw it and then extend it out here and call that A. Now, I have no idea how it's going to look. But right now, it's called thinking. All right? So I've got that taken care of. And I've got that taken care of. And side A, which is this one over here, is 25. So we know, 25.1 meters. We know this angle is going to be bigger than what? It's going to be, the angle is going to be bigger than 55.40. Okay? But we have angle B and side B, so 8.94 over 55.40 is equal to, and we've got 25.1 over sine of what? A. Oh my gosh, we're going to have to use some algebra. All right, go to it. Now you got to get used to drawing pictures because we're fixing to go into physics. We're fixing to go into vectors and polar coordinates, and you're going to have to draw pictures called dang old diagram. What kind of diagram is it called in physics? Anybody
Force
remember?
diagram.
Huh?
Force diagram.
I am just impressed. So, sine of A times 8.94, dang old algebra, is equal to 25.1 sine of 55.40. Divide by 8.94. Divide by 8.94. And then take the inverse what? Inverse sine, Hubert. That's right, class. Of 25.1 times the sine of 55.40 over 8.94. And somebody give me that number. Pendleton, shout it out, and easily shout it out whenever you get it so I can ask Anderson if they verify it. 25 times the sine of 55.40 divided by 8.94, then take the inverse sine of that number. What do you get? Okay, we'll wait 30 more minutes. Easily, y'all wait.
I got 2.3.
Okay, we got 2.3. I don't think that's going to be right. Because it has to be greater than 55 degrees.
I'm getting error.
Is it because the degrees is in degree in minutes and not?
No, well, you got to type it in minutes and seconds, or you can change it to a decimal. You need to do that. But it should give you, unless I've done something wrong, I don't think I have.
Oh, sine A.
It is sine. Okay, but do the inverse of, you didn't do the inverse. You did 2.3, do the inverse sine.
Sure.
Okay, I said that. Okay. All right, so I said that, I just didn't, okay. Why? Okay, since you got an error, and plus it needs to be greater than 1, I said it wasn't going to be right, and what told me that was this 8.94. Okay? It's going to be very hard for you to get 8.94 with a 55 degree. I knew there was something up with this thing then, but I didn't say anything. But when you did the 2.31, that told me, and you got an error, that should tell you that the angle does not exist. Okay? Because, see this 8.94? It's not going to touch.
Oh, is it?
Okay?
Okay.
So it's not going to exist. I would have done this question after we have done a couple of questions, and then I would have done this question. This is not the one to start off with, but
It's a demonstration of how the angles need to add up.
yeah, I would have done it afterwards. Okay? Okay, here, why are they showing us the whole thing? I don't want to show the whole thing. Why are they showing the thing? I don't want to show it. Okay, evidently something's wrong with this because you're not supposed to. Okay, let me go back here. And I don't know about, I can't do it here. Hold on a second.
18.
Just get the drive. They're going to get up there. Just
All right, write that down.
That's good.
Solve the triangle if ABC, if A is equal to 55.3, and basically they've got it drawn out right here, and I want you to find the angle, and I want you to find side C. Because you're talking, you know, if I could give y'all a test on 10.1 and 10.2, and hopefully all of you would ace it.
Mm-hmm.
Because that's basically what these are going to be. But I got to throw something in there. I got to have you on a section you don't know how to do, because I got to have some of y'all fail. I'm kidding. That's a joke. What? I'm going to skip that out. I don't want to have to. Y'all bear with me a second while y'all are working on that. I'm lazy today. Okay, there's our question. And we've got I don't understand what I need to do to make y'all understand. Pay attention. All right, 53. Right there, side A. There's side A. So we've got 22.8 over sine of 55.3 is equal to, and pick out what you want. I don't care. It looks like we've got B, so we're going to use sine. We got B. Okay, we need C. So what is 55.3 plus 63? What is that? 119.2? Somebody do my math. What is it? What's 55.3 plus 63.9?
Oh, it was 119.2.
Okay, subtract that from 180.
60.8.
60.8. So 60.8 over C.
22.
And multiply that through, and you're going to get 22.8 times the sine of 60.8 divided by sine of 55.3. And somebody crank that out.
24.2.
Pendleton, you got 25 point what?
24.2.
24.2?
Yes, sir.
Easily?
Hubert? How did we get the angle for B 63.9? It's not in the question.
They did law of sines and law of cosines. I mean law of sines. Because you have an angle here. You have an angle here. They gave you that angle. And you have the two sides right here. They got that by using the law of sines. That's why I don't understand the slide. I don't understand why they did all that. Yeah. That's the first thing you do is find B by using these three right here. These are given.
Gotcha.
And I just went ahead and found side C. Okay, 24.2 should be your answer for C. And plus, they could give you all the angles. They could give you one side and two angles. They could give you two sides and one angle. They could give you all different looking. I don't know why they started this question like that, but maybe they just threw that in there. I don't know. I don't like sometimes I don't like the slides, so I just go through and make sure I cover everything. That's why I use the slides. See, they only give, yeah, that's what they did first, right there.
I was just making sure.
Yeah, I didn't see that. Okay, next question, or next. Let me go back to the. There we go. I'm looking. There it is. I think that's what we got, didn't we? Okay.
No, what was the answer?
I'm looking to see what else we got to go over. Okay, solve angle, and try not to look at the answers. I don't know why they're showing the answers all of a sudden. They're not supposed to do that. It's supposed to be blank. But anyway, I'm going to draw a picture. All right, solve the triangle ABC. Given that angle A is 43, so 45 degrees would be something like that, right? So 43.5 would be right here. And then we've got A, this is angle A, so little a would be over here somewhere. I'm just going to draw it like that. Little a is equal to 10.7. And angle C, which is usually top side, is this side over here is 7.2. So we got to find angle C. We got to find angle C first. So that's going to be 43.5 over sine of, I'm sorry, I just messed that up. I think by the end of the day, my brain is mush. All right, 16.7 over sine of 43.5 is equal to 7.2 over sine of C. And you're going to crisscross and take the inverse sine. So that's going to be sine of C is equal to 7.2 times the sine of 43.5 divided by 16.7. And C is equal to 7.2 sine of 43.5 over 16.7, and you're going to take the inverse sine of that. And somebody tell me either you're going to get an error or you're going to get the answer.
Where did the 16.7 come from?
Wouldn't it be 10 point stuff?
10.7, right?
Yeah, 10.7.
Okay, people, 10.7. 10.7, I'm sorry, I mistaked my 0 for a 6.
Apple's the best of us.
Which does.
All right, did y'all come out with 27.6?
Yes.
Okay, now you've got 27.6. You can find angle B, and you can find side B. So I can go ahead and find that. So 27.6, 70.1 or 71.1?
71.1.
71.1 to give you 128.9. What do you get for angle C?
I'm trying to find it.
108.9.
What'd you say?
108.9.
108.9. I don't know what I said, but all right. Now you got the angle C. You can find side C. I mean side B. That's angle B. Now you can find side B. Someone find side B for me. Y'all don't know how to feel and know what you're doing, do you? That's supposed to be a joke. Huh? It's an interesting feeling, right? So what do you come out with side B? Let's see if it just carries it on to the next. Yeah. 14.7. And hopefully you feel good about yourself. And that is 10.1. 10.2, I'm going to go ahead and show you 10.2. Yeah, law of cosines. And I'm just going to the page that has it. There is the law of cosines. I want you to go ahead and write those down, and we will basically, because some of y'all are going into convulsions, we will basically go into that next. Let me put it on the slide.
Hubert, can you make it bigger?
There you go. How's that?
Thank you.
Already doing it.
Did I already call the roll?
No.
I have to call the roll because we don't want perfect attendance.
I do.
Well, not in school. If you have perfect attendance, teachers send in perfect attendance too many. They email all the teachers and say, we can't have too many perfect attendances.
Perfect attendance is for a class or for a person?
Basically, they know that the teachers are gaffing off the attendance and putting in all yeses. And we all know that attendance is important. Much more important than teaching, isn't it? Coming from people that use posters in innovative learning. I thought innovative was mean like aggressive. Always changing. I thought that was innovative. Yeah. Evidently, I've got the wrong definition. Retro means, what do you call it? What do you call it when somebody, no, that's denial. Aggression. There we go. Regression. Y'all going somewhere? I'm going to say something to y'all like I tell my 12-year-old. Why do I get mad? Is it because that I don't have a life, or is it because that I'm temperamental, or is it because that I'm provoked? Yeah, it's Charlie. Good gracious, y'all think just because I'm not in the classroom that y'all can just do whatever you want to? No, it doesn't work that way. Okay, let me pull up before some of y'all explode.